Question 39. So this question was quite a tricky question. There was several components to it. So we'll start with what information we're given. So it tells us that ethanol is a clear colourless liquid that is generally derived from grain or sugar. It can be blended with petrol in various proportions in order to produce a fuel with a lower carbon footprint. So a laboratory experiment is set up to determine the percentage ethanol in ether gas, a fuel consisting of ethanol and octane. So they've taken 5 grams of the fuel, combusted it in a bomb calorimeter, and the temperature of the calorimeter changed from 15.5 to 90.17. Okay, so that was when the fuel was combusted. I'll just change colours. Okay. Next information, it says a current of 2.75 amps was then passed through a calorimeter for 90 seconds with a voltage of 6 volts. The final temperature of the calorimeter was 90.651 degrees Celsius. So it's given us the information of when they are trying to work out the calibration factor by putting through the current and the voltage, and they've also given us the information about what happened when the fuel was combusted. So part A says determine the calibration constant of the calorimeter. So to work out our calibration factor, we do voltage multiplied by current multiplied by the time divided by the change in temperature, okay, when they were doing that calibration. So all we need to do is take the values from the information. So we've got our voltage of 6 times 2.75, and that was done for 90 seconds. Remember, time is always in seconds. Divide by the change in temperature. A little bit of confusion about which one to look at. The first information, they were combusting the ether gas, and it went from 15.5 to 90.17. Then they passed the current through, and it increased to 90.651. So we want the change in temperature between 90.17 and 90.651. Okay, and that difference is 0.481. Okay, so we should come up with a calibration factor of 3087 joules per degree Celsius. Okay, so that's part A done for 1 mark. Okay, part B was a little bit harder. Okay, it says determine the percentage of ethanol in ether gas. So if we go back to the question, it told us that ether gas consisted of ethanol. So we've got, what's my pen? We've got ethanol in there. If I can write ethanol, and we've got octane. Okay, and we want to work out what percentage of that is ethanol. Okay, and we know that from the question we've got 5 grams of the fuel. Okay, so in the previous question we worked out what the calibration factor was. Using the calibration factor, we can work out what the energy released was when that fuel was combusted. Okay, so we've got energy. Working on. Okay, we're gonna I didn't type it up. Okay, we'll type it up instead. So we've got got ethanol and we've got octane in the fuel. Okay, so we can work out what the energy released is. Okay, we worked out what the calibration factor was in the previous question, and if we multiply our calibration factor by the change in temperature, and if we go back to this slide here, the change in temperature with when they combusted the fuel was from 15.5 to 90.17. Okay, so that's our change in temperature when the fuel was combusted. So we'll do 90.17 minus 15.50. Okay. Okay, and that gives us energy released of 230.506 joules. Okay, I'll convert that to kilojoules. So 230.5 kilojoules. Okay, so 5 grams of the ether gas released 230.5 kilojoules. That's what I've worked out so far. But I need to use that information to work out what the percentage of ethanol is in ether gas. Okay, but I have no idea. I know that they've used 5 grams of fuel, okay, but I don't know the mass of my ethanol. Okay, don't know what that is, and I don't know what the mass of my octane is either. Okay, let's do that down. Okay, I don't know what that is either. Okay, so I'm going to have to use some algebra to work it out. So if I make the mass of ethanol is equal to X, and the mass of octane, okay, I know it was 5 grams altogether, so it would have to be 5 grams minus the X. Okay, that would tell me my mass of octane. So I know that the ether gas released 230.5 kilojoules. But how can I work out what this mass of ethanol is? Okay, so if you go to your data booklet, you will see that you have got some information to help you answer this question. So we've got here octane. Just put it separate. Okay, we've got octane and we have got ethanol. Okay, so from my data table, from my data booklet, this is table 11, it's telling me that for ethanol, for every 1 gram of ethanol that is combusted, 29.6 kilojoules is released. When octane is combusted, for every gram, 47.9 kilojoules is being released. Okay, so I have got some information that I can use. So I can use that information from my data booklet to try and work out what the mass is, or to work out what the mass of ethanol is out of that 5 grams. So I know that it's going to be, from my data book, 29.6 X, okay, plus, and my octane's 47.95 minus X, okay, and that is equal to 230.5 kilojoules, okay, because that's energy released. Okay, so I'm trying to work out what the mass is, because it does 29.6 kilojoules per gram plus 47.9 kilojoules per gram, but I'm subtracting it from the 5 grams, will release 230.5 kilojoules. Okay, so it's a little bit of problem solving with this one. So then if I just simply solve the algebra, so what I'm going to do is I'm going to expand my brackets. So 47.9 times 5 will give me 239.5 minus 47.9 x, and that's equal to 230.5 kilojoules. Okay, then if I simplify my like terms by grouping them, I've got 18.3x, and that will equal negative 9.15 kilojoules. Okay, so then that will tell me that x is equal to 0.5 grams. Okay, so by using my algebra, I've been able to work out that the mass of ethanol in the 5 gram sample to release 230 kilojoules, 230.5 kilojoules, I need 0.5 grams of it. Okay, that's not the end of the question though. So I've worked out the mass of it, but it wants me to determine the percentage of ethanol. So if I know that I have 0.5 grams out of 5 grams, I work that out as a percentage times 100, and that is going to give me an answer of 10%. Okay, so it was quite a tricky question, that one. Okay, but you have to remember what information you've got given to you in your data booklet. Okay, and make sure you're using that as a resource. Next question, question C. If the power supply in the calorimeter was faulty and delivered a voltage less than the expected 6 volts, what would be the effect on the calculated percentage of ethanol in ether gas? Okay, so we remember we had calibration factor was equal to VIT divided by change in temperature. Okay, so what's happening is we are getting less voltage. Okay, so if there's less current, that would mean that I'm not going to be able to be heating it up as much. Okay, so because of that, there's going to be less energy released because I'm not putting as much voltage in, so there's going to be less energy released, which means that there's going to be a smaller change in temperature within that 90-second period. Okay, so because remember the time was 90 seconds, so because say it's delivered less voltage, say it's 3 volts instead of 6, it's going to release less energy from that fuel. So there's going to be a smaller change in temperature. Okay, if there's a smaller change in temperature, that means that my calibration factor is going to increase. Okay, according to this equation here. Okay, so I've got a smaller change in temperature, my calibration factor is going to increase. Because of that calibration factor increasing, that means that when I calculate the energy content, energy, if I can spell, calculate the energy content of my ether gas, that's going to be larger. Okay, that will be larger. Now, if we looked at our ether gas from our calculations previously, in that 5-gram sample, I only had 0.5 grams of ethanol. Okay, so that meant I had 4.95 grams of octane. So that tells me that ethanol had a lower energy content than the octane. Okay, so if I'm getting a larger energy content for the ether gas, that would tell me that the percentage of ethanol is going to be lower to be lower. Okay, just because it is that lower energy content fuel. Okay. Question D, why is ethanol considered to be an eco-friendly fuel? So if we remember ethanol, we can make it through the fermentation of crops. Okay. When we are burning those crops, it releases carbon dioxide into the atmosphere. But in the process of growing those crops during photosynthesis, they're removing carbon dioxide from the atmosphere. Okay, so that's why it's considered to be an eco-friendly fuel. Okay, because it's balancing out what it's releasing with what it's removing from the atmosphere during photosynthesis. Question E. Ethanol energy from ethanol can also be converted into electricity using solid oxide fuel cells as below. Okay, let's enlarge this so we can start annotating the diagram. Okay, so I like to have a look at the diagram first, see what information the diagram's giving me before I have a look at the questions. Okay, so I've got ethanol energy from ethanol can be converted into electricity. So it tells me what my fuel is going in. So I've got my ethanol going in, and I've got air, oxygen going in. Okay, it tells me up here my electrons are moving in this direction. So this would make it the anode. This is my cathode. Okay, so ethanol's undergoing oxidation and the oxygen here is undergoing reduction. Okay, so I've had a look at that from my diagram and some of the information I've gathered. Let's have a look at the first question. So it says the overall cell equation and the reaction occurring at the anode are shown below. Okay, so this reaction here. So I've got my ethanol will be oxidized and then it's reacting, okay, with my oxide to produce carbon dioxide and water, and then I've got my overall reaction. Okay, so part I, didn't cut it in, says I need to write an equation with the reaction occurring at the cathode. Okay, so I've already identified before when I had a look at this diagram that this was my cathode here on the right hand side, and I've got my oxygen. Okay, so I've got my oxygen going in. Okay, remembering at the cathode, that is where my reduction occurs. Okay, so I've got my oxygen gas going in. I'll leave a gap from there. Okay, so I've got oxygen going in. It's being reduced. Okay, and the diagram's a little bit blurry on here, but you can tell from the picture in the homework booklet that it is being reduced to my oxide ion. Okay, so I'll make that 2 minus aqueous. Okay, then if I have a look at this, Okay, I've got oxygen. Okay, yep. Okay, I'll balance it out. So I've got 2. Okay, so I've got 4 negative. Yeah, honey? Can you wait 2 seconds? Just in the middle of the video. Can you just listen? Yeah, in a minute. Okay, so we've got a 4 negative charge over here, and we've got neutral here. So we want to balance those electrons. So on the left, I'm going to have to add 4 electrons. Okay, and this is a reaction that's occurring at my cathode. 2. Explain one advantage and one disadvantage of using an ethanol solid oxide fuel cell to generate electricity rather than a conventional coal-fired power station. Okay. Yeah, that's fine, sweetie. So one advantage. One advantage would be that in a fuel cell, we are generating or we're converting chemical energy straight to electrical energy. Okay, so we're not getting that heat loss that we get in a conventional coal-fired power station. One disadvantage would be that fuel cells are quite expensive because they're using the platinum catalysts. 3. List 3 functions of the electrodes in a fuel cell. Okay, so 3 functions of the electrodes in a fuel cell is that they need to be able to conduct electricity. They need to separate our oxidizing agent and the reducing agent, because remember in our galvanic cell, when we have the 2 half cells and they're separated into individual bakers, for example, they can't come into contact. Okay, it's the same in a fuel cell. Okay, the oxidizing agent and the reducing agent to generate that current can't come into contact with each other. So remember, those electrodes will only let certain things through to the electrolyte in the middle. Okay, so it needs to be able to conduct electricity, needs to be able to separate the oxidizing and the reducing agent, and these reactions are quite slow, so they need a catalyst as well. Okay, so that the reaction can occur in a timely manner.